Now that we have an idea of the vast impact 3D printing has made and can make to the future, in this video, let's talk about how 3D printers work. At its core, a 3D printing process comprises of the following steps. First, you create a design in a 3D design software. Then you convert it into an STL file, where STL stands for Standard Tessellation Language. This is a fancy way of saying that this is a 3D file with XYZ position of each and every point on the 3D part. An STL file does not include any color that you may see on the 3D part design on your computer. Next step is to import the part into a slicing software. This software produces the layer by layer understanding of the 3D part. Depending on how finely we slice the 3D design, that defines how smooth will be our 3D printed part. Also, a finely sliced 3D part takes relatively much longer time to print. The final step is conversion of the sliced model into a language that our printer can understand. This language is called the G code. A G code is a programming language that tells the motors of the printer where to move, how fast to move, and what path to follow. Once the printer has the G code, now it robotically 3D prints the part without any human intervention. No matter what type of 3D printing process we work with, these steps always remain the same. Now let's segue into the types of 3D printing processes. These are commonly categorized into three types: FDM or Fused Deposition Modeling, SLA or Stereolithography Apparatus, DMLS or Direct Metal Laser Sintering. Those are a lot of fancy buzzwords. Let's break it down and understand each of the process. FDM is a process that converts a continuous roll of filament into a 3D printed part. The filament material is fed from a large spool through a moving, heated extruder nozzle of the printer and is deposited on the growing work. This is the process that our Ender 3 printer follows. There are a variety of materials that can be printed using an FDM printer. We are using PLA or polylactic acid, which is the most commonly used 3D printing material out there. It is derived from corn starch, tapioca roots, or sugarcane. This is also biodegradable, though it takes years to degrade. There are other materials like ABS or polycarbonate that can be 3D printed. These materials are very commonly used to produce parts like water bottles, Legos, and many parts of things around you, like TVs, headphones, etc. Let's move to the next process. SLA or stereolithography apparatus is another 3D printing process that is very different from FDM. This uses a photochemical process. Photochemical is made up of photo, meaning light, and chemical, meaning change in the chemistry of the material that's used for 3D printing. This 3D printing material is found in liquid state and is also called liquid resin. During a photochemical process, a light source, for example a laser, illuminates specific locations on the bottom end of the tank that contains liquid resin. This light converts liquid resin to solid 3D printed layer. Layer by layer, the part is produced upside down as the light source is illuminating the material from the bottom. SLA printer can print parts out of similar materials that we discussed for FDM printer. Parts printed using SLA printer have better surface finish than FDM printer, but it is also a more expensive 3D printing process than FDM. The last process in this list is DMLS, or simply metal 3D printing. This process involves forming each solid layer of metal from its powder form by heating it with laser. This process of heating the material and converting it into solid metal is called sintering. Similar to the SLA 3D printing process, DMLS involves selectively pointing a laser beam on the 3D printing material. Unlike SLA, the material that is used for 3D printing here is present in powder form. You can print parts out of metals like steel or titanium. We looked at an application of steel in the last video for creating parts of rocket engine. One application for titanium includes creating implants for joining broken bones or joints in human body. Now that we went through learning what is 3D printing, why is it important, and how it works, we know a thing or two about 3D printing. We will learn so much more in the coming weeks by creating our own 3D printed parts using additive, layer by layer manufacturing robotic process that we will use to change the world for the good through our FDM Ender 3 printer. You see what I did there? I hope you are excited to dive further into the world of 3D printing.